produce a lot of pounds of kelp in the end. But I think we're going to find, and we already know this from markets in Asia and elsewhere in the world, that a particular phenotype, the way a plant looks, is preferred. So maybe wide blades, long blades, thick blades. So that can be just as important as the amount of biomass produced. So if we take a look at the impacts that the line spacing would have on these different parameters. And then determining the impacts of line spacing on the percentage and type of biofouling. So we did look at biofouling. So that would be, when we talk about biofouling, that's the things that grow on kelp. Kelp is an excellent structure. It's a foundation species, and it creates habitat. And even the surface of the kelp recruits a lot of things that grow, like little microalgae, other organisms like bryozoans. You'll find that it's home to things like amphipods and copepods and even some sea slugs. So it's really kind of a cool thing, but maybe not so cool when you're trying to sell the kelp into a food market. So we just wanted to see if the line spacing had any impact on those parameters as well. And then determine the percentage of nitrogen and carbon content in Alaria marginata growing in different line spaces. And why would we measure this? Well, when you have suboptimal growing conditions, we know this from terrestrial plants, the ratio of carbon, that's the products produced as a product of photosynthesis, and what you need for photosynthesis to generate the things like chlorophyll, you need nitrogen. And if those ratios are off, they can show that they're missing one or two of those key components and that their growth isn't optimal. And so we thought we would measure this as well, just to see if there's maybe some stress in growth. And so overall, what we're doing is we're just measuring if there's an effect on any of these parameters. We weren't trying to find out what the actual cause was. So we're not going to say that it was light stress, nutrient stress, or stress because they're too close together. We were just looking at what the effects were of the different line spacings. And this will, again, probably vary and be site-specific. So this is hopefully a methodology you can take. You can build an array like this, I'll show you next, and test it on your own farm in your location to see if what the line spacing is in your particular area of Alaska. And so we made these spreader bar array systems. You can see it here in the bottom deployed. This is us seeding it here at the top. And shout out to my husband, Alf Pryor of Alaska Ocean Farm. So he's the one who put all these together for me. That's a lot of work. We also did the line spacing. And we went with these spacings because they're kind of the most commonly used spacings. I kind of called some farmers and talked around, and they have spacing anywhere from typically 6 feet all the way down to 3 feet. Some go a little bit bigger, up to 10 feet of spacing. And then I wanted to see what would happen, of course, if you really push those limits and went all the way down to 1 foot of spacing. So we randomized the locations for each treatment within the arrays. So each array itself, there were 3 of them, and then they had line spacings of 6 foot, 4 foot, 3 foot, 2 foot, and 1 foot. And it randomized just where those were within each one of those arrays. And each one of those arrays is about 30 meters apart, 60 feet apart, in a section of our Calcin Bay farm. That's the Alaska Ocean Farm's Calcin Bay farm in Kodiak. And it's in about roughly a 1.25 acre area. And it was seeded with commercially grown seed line, and the seed line was stocked at about 2,500 spores per bill. We outplanted these seed line arrays, seeded them January 8th to 10th in 2022, and the 19th to 20th in 2023. So we deployed it for 2 years and measured the same parameters over the 2 years. Put everything back exactly as it was the second year and tried it again. So here's an overview of the arrays, and they were named the North Array, the Middle Array, and the South Array. Really creative, just because that was their orientation on the farm plot. One to the north, one in the middle of those two, and one to the south. And you can see how we've spaced the different treatments within the array. You can kind of see the here on the North Array, there's varying numbers of lines depending on the line spacing. And so you could basically, this is how much line and ultimately seed line you'd have to buy in these different spacings. And so you can see when you get down to 1 foot, you actually have 13 lines, which gets to be a lot. But when you're at the 6 foot spacing, you only really have kind of 1 line in the middle, so a total of 3 lines. For experimental purposes and for our sampling, we only measured the lines that were shaded by a cohort line. So the outside edge lines we did not measure and count in my final results because they were shaded on one side or didn't have a spacing cohort. And so here's a view. Sorry, it's not a little bit brighter, but this is the array. This is the north array deployed just right after deployment in Calcium Bay. This is an aerial view to show what the arrays look like. The spreader bar system, these are aluminum bars, and they're held in place by 2 anchors on either end. And this setup allowed it to remain at an optimal kind of 7 feet subsurface. And that's kind of where the kelp likes to be. It doesn't want to go too deep where it doesn't get enough light. And it doesn't want to be on the surface where it can get beat up by storms or frozen due to freezing temperatures. Just to give you an idea of where it was, up here we've got a little map here. There's Kodiak. It's about 14 nautical miles, 26 kilometers from the port of Kodiak on the harbor. And it's got a little peninsula that sticks out here from mainland. There's an island here, a reef kind of on this side, so the submerged reef. And then here are the arrays and the orientation of the arrays on the farm site. And for those of you who may not know, Kodiak is right here in the Gulf of Alaska. And we're here today. So. All right, methods, yield and measurement and phenotype measurements. So basically, there's a lot of kelp out there, and we couldn't measure every blade produced in the plot. That would have been absolutely nuts. I would have liked to have done it. That would have been some awesome data, but we just could not do that. So when we were doing and calculating our growth rate, we just took random 10 centimeter sections from each of those row lines, excluding the outside lines, marked them off with a piece of flagging so we could come back to them. And then that was just one per treatment. And then the length of the longest blade, we measured the specific growth rate. So we just took that 10 centimeter section, measured it, and just measured the longest blade. And again, maybe it was the same blade, maybe it wasn't that we measured every time. But again, it's hard to, even in that 10 centimeter subsection, to come back to the same blade every time you measure it. So that was the method we used. And then the kelp was harvested and sampled, and that was done in early June each year, just a few days apart year to year. And from each of the arrays, we calculated the kilograms per meter, or the pounds per foot, of the kelp that was grown within each test block of the array. So we just brought the lines in, cut it off, and weighed it on the deck of the boat. It was loads of foam. And we did a kilograms per treatment. So again, kilograms per meter, kilograms per treatment. And then we took from each of the lines, again, not the outside lines, but those lines that all had a cohort on either side that was part of the line spacing experiment. And we took a 1/2 meter subsample. And from that subsample, we measured the following. We didn't do this in the boat. We took these samples back. And thank you very much to the Alaska Sea Grant Program and the Kodiak Seafood and Marine Science Center. It's over at University of Alaska Fairbanks. Really has used the pilot plant to do that because it was much nicer to do that on the deck of the boat. And we had access to a refrigerator where we could keep samples fresh and in prime condition before we had time to measure. And so we took the total weight and of all those blades in that 1/2 meter subsample, and then we took the weight of just the holdfast. And why would we do that? Well, what's interesting is the kelp now, when it's cut off the line and sold, currently processors and buyers are only paying for the blade weight. They're not paying for anything else, not the holdfast. And so I just wanted to know what kind of the waste product weight and weight of the waste product was coming off of those 1/2 meter subsamples, just so we could get an estimation of what biomass actually grown and produced would actually not be sold. And then we counted the density, so the number of the thalli or the plants present in that subsample. And so its first year wasn't too bad. Second year, we'll see as you see my results, the density was insane, and sometimes hundreds of plants. And so we counted each one of those plants in the subsample. And then from 10 random plants within that 1/2 meter subsample, we measured the following. So we took the percent biofouling coverage in species. We just kind of looked at the blade and saw how many little creatures were on there and other things. And then phenotype. We looked at the thallus length. So again, we measured the plant length, the width, the thickness. We assessed fertility. And this species of kelp, ribbon kelp, is really helpful. It has what's called sporophytes at the base of the blade. And these sporophytes are the reproductive blades, and so we just visually assessed fertility. We didn't actually like see if they released biospores or anything fancy like that. We just kind of visually assessed to see if they were fertile or not, or even had sporophylls present. And then tissue samples from the middle line of each array, and again, that was for that carbon and nitrogen ratio analysis. And again, did not sample those outside row lines. So here's just nice pictures of us sampling, and you can see here harvesting into a tote. And this is similar. Some farmers are still doing this around the state, pulling the line in by hand and harvesting in. We've kind of moved on for that to mechanical cutting methods, but just in because of the structure of the test arrays, and then because it was just easier to do this for us, because we were taking and weighing subsamples, we just cut it right off the line. We tried to get as much of the biomass, including the holdfast, in that sample. And then here, this is measuring back the pilot plant. This is an example of a 1/2 meter from 3-foot spacing. And we just laid out a ruler on the table and went to town measuring. We would measure blade width and length with a ruler. We measured blade thickness with a digital caliper. And then we had some nice balances here, not pictured, for doing the weight. And then just to say, and do our due diligence, that yes, the oceanographic parameters were the same at each of the 3 locations, even though they were pretty close to each other. We would have had to measure the following. We measured water flow with current meter, measured flow rate and direction. We measured light with a Secchi disc. We tried an Apogee quantum light meter, which proved difficult. And then a hobo water, which didn't measure in PAR or photosynthetically active ingredients like we like to do when we're measuring light for photosynthetic organisms, but we used hobo logger, and that gave us kind of a running tally. It takes measurements like every 15-20 minutes, which is really cool, and it includes temperature too, which is nice. And then salinity, so we just measured how salty the seawater was, basically, with meters especially. And all these measurements right after the health is right after the lines. And the temperature through both a little ground sample with the YSI measuring salinity, and those global logs continuous forward and it snapshot you want to gather it from, and took subsamples of seawater and had those analyzed by the lab at UAF, and it was pretty cool. It was nice of them to do that for us. And we did that 3 times each location. We did that about 2 times per month as we could get out there. We did that through January through June. Results. Here's the juicy stuff. So, what happened? And I'm not going to go through all the results tonight. You can certainly contact me offline because there was a lot of data, and a lot of it proved to not really show much of anything or much of a correlation to line spacing. But what was really interesting, and this is yield, so we did see patterns in yield, which I thought was really cool. And so on the top, we have the total harvested biomass, and that's like the kilograms per meter or the pounds per foot. And what's really cool is that we do see a pretty strong trend, and that's 2022 on the left and 2023 on the right. And we do see a pretty strong trend as you go from 1 foot down here up to 6 foot here. You can see that the average kilogram per meter increased. And as our line spacing got closer and closer together, our harvested kilograms per meter decreased. And same thing in 2023. And this is interesting. This is looking at just the total harvested biomass. So that's when we took, sampled into all the totes, weighed them all, and then averaged it by the number of people per line. And there was a slight difference between our subsamples as well. And it was about a 35% difference. That's what we have here on the bottom. This is the total sample biomass. And so there's a so this is the sample biomass for the subsamples. And what I think is really cool is that you see the same trend. There's a little thing here before with some hyperlation in 6, but a nice regression here. And what was interesting is that they're about 35% different from one another. And I think the reason that that is that it happened to be that these samples got a ride back to town in the boat, and they had time to drain the excess water off of them. So we lost quite a bit of water weight. This brought up an interesting point, and I think this is an interesting point for industry, that it's hard to weigh kelp because it does hold on to a lot of water. And calculating a fair weight for buyers and for farmers can be a little difficult. So that might be something to look into further and further research and stuff, and calculating, maybe it could be a localized effect, or maybe it's kind of the same for all of Alaska. What's the water reduction ratio that makes sense for seeds? Yeah, 35%. So here's blade length, and I thought blade length was really nicely illustrative of an effect. And again, this is phenotype, so this is what the kelp looked like. And again, this could be important for your markets if you're a kelp farmer, because maybe it's not all about just growing many, many pounds of kelp. Maybe it's more about growing kelp that looks a certain way for a certain market. And so this is 2022, this is 2023, and these dashed lines represent the mean or the average blade length. And you can see that purple is our 6s are purple here, and it's definitely in the lead, although in 2023 it was slightly behind the 4-foot spacing, but obviously 4-foot, 6-foot, 3-foot spacings kind of produce bigger plants overall. And I thought that was pretty interesting, and that was analogous to what I kind of predicted in my initial hypothesis. So here, this picture illustrates what we saw, which I thought was really telling, and that you really do see this effect, and the data showed that there was a significant difference between some of these, definitely between 1 and 6 and 3 and 4, but not maybe between 2 and 1, not maybe between 3 and 4, not maybe between 4 and 6, but you can see if you, at our farm site, want to grow tiny kelp, you should have 1-foot spacing. If you want to grow big kelp, you might have 6-foot spacing or 4-foot spacing. I'd probably go for 4 because I can grow a lot more kelp in 4-foot or 3-foot than I can in 6-foot. So we're starting to lead somewhere here with some of this information. Again, this was at our farm site in Kodiak, Alaska. If you have a farm site here in Prince William Sound, to different oceanographic conditions, all these results could very likely vary. And so what this really was a setup to find a way to test for this, not so much say, for all of you in Alaska, this is what I do. And then again, this was repeated in 2023. This is just kind of going from the opposite direction. This is 6 down to 1 foot here. And so again, results were repeated 2 years in a row. And then these aren't particularly interesting. They're kind of a little all over the place, especially in 2023, but this is over here. This is the blade width. This is 2022, 2023. Down here we have our line spacing from 1 to 6. And then this is the blade thickness, and how thick the blades are. Definitely as blades typically get bigger, they get a little thicker. That's kind of what we saw. So that's one of the other comparisons I'd like to make, is just the comparison between blade width and blade thickness, independent of the line spacing. But you can see here that there is a little bit of a trend line, at least for blade thickness in 2022. Blade width was a little weird in 2023. I don't know what's going on there. But one thing that we saw, and this leads into another conversation, is when we looked at density, we did see kind of something strange happening. I think that's why the blade width and thickness got a little weird in 2023. So density, there doesn't seem to be a strong pattern with the line spacing here and our blade density. And here again, we have had lower density in the 6-foot, other ones. But here in 2023, we've got a lot of density in the 6-foot spacing. And so what I think is going on here is to give slides and stuff. That surprisingly, this was independent of line spacing altogether. This has to do with the kelp seed line. And so the kelp seed line itself it's grown through a process where we take wild kelp, we induce it to release little motile spores called myospores, Those are randomly dumped in a vessel with one of our seed spools. That's how we inoculate the seed line. And so this process is very inaccurate. We cannot control how many of those myospores decide to recruit on that seed spool. And it can vary greatly. So although we say that our stocking density and the number of spores, with so many spores per milliliter in that seawater, put our seed pipe in, we just have no way of knowing that that's going to equate on the seed line itself, how many baby plants will be there. And so I think this is what we saw, because we saw way more plants on the line. Densities were really high here. You can see that. We only got up to, like 250 plants was a peak here. But oh my gosh, like look at here, 1,000. We had a lot of blades per meter, or per half meter or subsamples in 2023. And so the sea line was just different, and I think that's what accounts for a lot of this variability. And so here's some pictures of what we saw. And so you can see here, that's really sad density. That does not look great. And that was in the 1 foot spacing in June of 2022. Saw high variability. What could cause this? Sea line, maybe this got rubbed off. Maybe a sea otter was scratching his back on the road. I don't actually know. But very, very small. And then look at how dense this line is here. This is the 6 meter spacing in June of 2022. It was absolutely packed with plants. And so if I had to guess, I would say that it had a lot to do with the stocking density of our seed line. And we tried, of course, to go with standardized seed line, but we failed. And again here, this is the 1 foot in June of 2023. Look at that, it's absolutely packed with little blades. And then this has not quite as many in June of 2023 on the 6 foot, but it actually had the highest density it's had. So and here are carbon nitrogen results. And these again are a little bit you see lower ratio means that things are very bad, that there is a skew ratio. Higher ratio, that's indicators here in 2022. But again, we didn't have a lot of samples. And so I want to look at it a little more in depth in the future and see if I can tease it apart. At this point, it doesn't look like there's a lot of strong pull one way or another for binding and the carbon nitrogen ratio. And the ocean is variable. There's a lot of things going on. And we didn't tease out what was happening. We can't say for sure nutrient stress that was only different. We can't say it was light shading or anything else. And we prefer research, but we can say that there were effects. So these are our next steps. And in a research project, you get somewhere, and a lot of times you end up with more questions than you answer in the research project, and that's okay. So next, I go next to my research. So this fall and through August 2024, it's just more data processing, working on my business. And then I think the most important component of this, and this thing I think is important, is a techno-economic analysis of those productive treatments. So I'm probably not looking at 1 and 2 foot spacing. And my pitch was for 3 foot, but definitely the 6 to 4 foot, deserves some attention for sure. And I want to just look, given the current cost of the seed line, of gear, these things, does it make sense to do it one or another, given the conditions of this particular site? And develop some formulas, maybe nice fresh farmers could use to do these estimations. Once they have an idea of how kelps perform, maybe we can test grain like this 1 or 2 years before they start farming. And something to note interesting in Alaska, the Alaska Department of Fisheries, and the Alaska Department of Resources will issue a permit, research permit, where you are allowed to lease a tiny kind of research project. You can grow kelp prior to the natural process happening. And then we'll really look at where the significant differences between treatments lie. Go a little bit deep at some of the things like the rate, utilities that seem to have, and we show those figures at the end. They don't really show much. They don't seem to be very much related to land spacing, but they are related to size. I think is interesting. So looking at some of those parameters of form depth, and definitely working with my advisor to not go down rabbit holes, as she calls it. So I have to be careful not to do that. But there's a lot of interesting stuff to see here, and I think there's a lot of analysis left to do. And I think this fall semester of 2024, which is actually starts in August, so I give myself a hard deadline, and then shortly they're published. And that's 56 published. I don't think a whole lot of people out are just the human race has always been and profitability of their culture. And with all the things going on, putting a large farm together. And so, it wasn't free. And I would like to in the end, save farmers making mistakes that we made, and the trial and error, and hopefully this is a way to do that. Great question. Yes.
Now that you're done with that leases project, are you still utilizing the spreader bars?
Yes, so the spreader bars are finding a new life in another research project this year, which is looking at our linear spacing of the plants. So how many plants per linear unit area of the farm line? So those little baby plants on the farm, how many is too many, or is just the right amount for bull kelp? What happens to bull kelp phenotype? So they've got a new life in a new project this year. We were not using them on our farm currently for ribbon kelp, but for another project. Any other questions? I was doing a great job. I answered everybody's questions through my talk. Oh, Jordan.
Really cool talk. So you showed that line spacing made a difference, but it seemed like you have pretty strong evidence that seedling density also played a huge difference.
It does. It really
does.
does.
One of your other maybe next steps is optimizing seedling density.
Yes, and it's something that drives me crazy. So my husband, in our world, we have Alaska Ocean Farms, and he's the farmer. He's the guy figuring all the engineering stuff out, how to put farms together, all that great stuff on the water. I'm the one in the lab trying to figure out how to just get baby plants to grow. And I notice things on the farm when we do stuff like this, but there are huge problems with the density. And it can vary wildly from year to year, like absolutely crazy density differences. And one of the things I would like to do is try to control density in the hatchery. I don't think we're ever going to get there with the bioscore seeding, but what's fantastic about kelp is that we can test it in different phases of its life cycle. And the second phase, it looks like pond scum. They're called comedophytes. You can grow them almost indefinitely. They're really tough. And what you can do is grow those comedophytes vegetatively, grow a bunch of them, and at a certain point, you can make them actually become reproductively viable and turn into little baby kelp. And you can take those little baby kelp, you can paint them on spools of seed line, and maybe that might be a way to better control density of the seed line itself. Some people have tried trimming, so they come in thin plots. Other ways to do it would be just to continue with the way we've been developing seed line. But instead of continually seeding the line, what we usually do is we feed the seed pipes or a spool of PVC pipes from around a piece of PVC pipe, and the farm line is spread through there. The seed line is tied off on there, and it just kind of pull the boat down, and it's pulled off and lines around lines. It's a continuous seed. There are methods where you could actually not continually seed, but intermittently seed the line. So what you would do is you open up the weave of the line, and then thread a small section of that seed line through, maybe only 6 to 10 centimeters, and then you close the weave back up. That piece of seed line is trapped in there and kelp goes from there. So you can alter density that way as well. So it might be a combination of those things. I don't know yet. But yes, we definitely need to get better control over the seed density. For species like Alaria, where we want to control the resultant phenotype, I think for species like sugar kelp, we've shown that those markets are just really interested more in biomass at this point. There may be other factors, like the carbon content and nitrogen, and then maybe other chemical constituents that kelp are affected by line spacing. And so there may be a reason to grow sugar kelp at lower densities, because perhaps it produces certain metabolites that are important to industry better in different line spacing. So I think this can have application to other factors of kelp as well, not just phenotype and maybe chemical constituency. I just don't know yet, but further testing. Other questions? Yes.
Is it always that flat on the microphone?
Always. It's always like that. Yeah. Mm-hmm. Yeah. No, it's usually really cruddy. Some of the difficulties of the project, that's why there's 3 arrays, and we have, replicates of everything. First year, one array broke in half because of tide and wind and horrible weather. Second year, we lost a couple lines, same thing, they snapped one of the arrays actually for a short period of time due to tidal stress and windstorm. those spur rays with their Achilles heels is they can get rocking like this, wave motion. And then if you have too much buoyancy on them, like too large a buoy, they can actually roll over across the system. And that happened to one of the rays for a short time. Unfortunately, it was only about a week. But yeah, stuff happens. Stuff happens out there. It is not fun working on the ocean. My recommendation to anybody who's thinking about graduate studies, don't work in the ocean. There were tears. There were tears at times. The first year we were just harvesting out of a skiff. We didn't have a big boat ready yet. It's crane. She's on some of those pictures, and we towed one of those sets to the beach on Calson Island in San Diego on the beach. That was not fun. Words were said. So, yeah, it's never easy. It's never easy on the water. And if you're all thinking about kelp farming, I highly recommend you go out and see what it's all about first. Because it is not fun at times. The pictures I took there I only took pictures because I was able to because it was nice. The other days, it was too cruddy to take pictures. So that's a great question. No, it's not hardly nice. But the kelp somehow still grows, even through all the fog and the cold and the dark and the mist, and that's what we're kind of learning too, is that, we talk about light maybe being a factor, maybe it's not, because these plants can grow under fairly dark conditions. Other questions? Got a little bit of time left for sure. Yes. No, I have not tried growing red seeds in the ocean. I have only done small tumble cultures in the lab setting. I've never tried to grow it in the ocean. Some of the confounding factors with that include they're very difficult to grow on seed line. So just like we grow the kelp seed line, red seeds don't have little mobile spores that swim. They have non-mobile tetraspores that just sink. So it's really hard to get a nice rounded spool covered in something. Some places have successfully seeded things like Delaware mollusk or thallus nets and things like that. So they just suspend pieces of kelp that's becoming, or seaweed that's becoming fertile over the top of the net in the aquarium, and little tetraspores rain down on the net, and then they've outplanted that. It's just really difficult to deal with. A lot of them are planted on lines like tropical seaweeds for alginate things that are spliced into the line. That's very labor intensive and also requires you to have a stock of those to do that. So I think most of those might really lie more with terrestrial culture, which again will can be expensive. You need a building to keep out of weather, you need lights, things like that. But I mean, if the species is valuable enough, but really good question. Not farm red seeds. We've had fruit on our farm runs for naturals, but yeah, we haven't growing them. Yes.
Do you have any results from your biofouling data, and what kind of findings have you had?
Yes, so not very fine. We have results from biofouling. There's not a strong correlation really with line spacing in biofouling. There did seem to be a little bit less of one of the types. We saw so few of like kind of the mobile species like snails and amphipods and things that it really was just a handful per year. A lot of those maybe got lost in the flourish or not what we were harvesting, sort of a thing. We did see what was really interesting. We had an outbreak of what we call a disease, and it was like little blisters formed on the legs of the cow. And these blisters, when looked at under the microscope, didn't have a defining pathology, except they kind of ended up putting a little hole in the tissue of kelp, the tissue around that hole of the product. He then sent away to a person who had a project called "What's Wrong with My Seaweed?" She's a researcher in France. I never heard back. I don't know if my seaweed got lost, and she never communicated again. I'd love to have known. We've had a couple people take a look at it. It just might have been at the end of its life. It was observed that in the wild populations around the farm as well, but there seemed to really be a lot of it on the farm. I don't know if that was due to just lots of plants in close proximity or what, but it was kind of ubiquitous throughout both years. We saw that on those plants. And it's something that came on later in the season, so plants are fine as we get into June, then we started to see that occur. And again, we just want to leave the kelp in both years to be consistent. We didn't know we would see it again the next year, and we didn't have any plans to harvest ahead of any biofouling. We just kind of wanted to see what would happen at the end of the growth cycle in June. Yes,
Yeah, what month were you on?
I harvested in June. Yeah, we all planted in January and harvested in June, and that was more anything due to convenience, just trying to keep it in the water for an average growing season. We got it out late the first year in January. Typically, people outplant in the mid fall, sometime like end of October, beginning of November, and we were busy with the commercial outplanting, and so we just postponed and ended up doing it in January the first year. So we continued with that same everything exactly as it had happened. Supposed to as exactly as it happened. The first year we outplanted in January. The second year, and again harvested in June. And the reason for harvesting in June was, let it go for quite a while and see what happened to growth. Did it start to slow down? Did it actually lose growth? And then again, we were competing with the commercial harvest, which happened a little bit earlier. And so science usually gets kicked to the end, especially when it comes to, actually the farmers making money. So we decided for June for the harvest. Any questions?
Thank you, Lexa. This was
Thank
great.
you. Thank you.